Containers and Virtualization. I don't actually know if this is lecture 18, by the way. It's just always been lecture 18, so that might be wrong. Cool. So you can find me on GitHub. It's GitHub WebSkill. Yeah. Okay, so you might be wondering, who the hell am I? So I graduated from NYU 2 years ago. So I'm not a TA. I'm not a student. At some point, I was an affiliate scholar. But yeah. I was the president of the Osiris Lab when I was here. Is anybody here from the Osiris Lab? Nobody. Oh, okay. Oh, yeah, gotcha. Yeah, it's great. They're on the 10th floor. You should go check them out if you're into any security stuff. So I'm a senior engineer and a partner at a company called Dynamics. I'll explain just a little bit about what we do there. But the main thing that I do is I created and I'm maintaining Anubis. So everybody here uses Anubis. Hopefully it has not been too terrible of an experience for everybody. Yeah, so let me explain like what Dynamics is. We're basically like the Swiss Army knife for options analytics. So like, options, derivatives, that type of stuff. Some of the math is extremely complex and you basically need a PhD in physics to understand it and to apply it. So yeah, we basically sell software that solves things like 100 times faster, 100 times more accurate than any open source solution that does these types of calculations. So specifically like options pricing and volatility fitting. If anybody's interested in that, yeah, let me know. We are hiring as well. If anybody would like to apply, I am not going to sugarcoat it. You need a pretty strong math background. So yeah, and also C++ because the finance world uses C++. Okay. Yeah, the finance world, we still use C++. Yeah, so you're, do they still teach, what is it, object-oriented in C++? Okay, good. So it wasn't for nothing. Yeah, cool. Yeah. All right, so, and then also next semester, I might actually be teaching a class here at NYU. We've been talking about this with Gustavo and I for a very long time. It seems like it might actually happen this time. So the whole idea is that it's applied containers and orchestration. So it's like basically everything that I show you in here, I have to like go really high level and I can't explain anything really in detail. So put it in your course reviews if you want that class to exist, because I would very much like it too. Yeah, it's basically like everything that they don't teach you about Docker in the normal courses. Cool. All right, so what are we going to talk about today? We're going to start with virtualization and VM. So this is sort of like the old way of doing things. This is the way that I like to think about it, but it still very much applies to everything that you'll end up doing in the real world. Okay, so until today we've been talking entirely about physical machines. So that means that it's a collection of real hardware resources. That means that the operating system itself can actually touch those resources. And everything, it's all exclusive access. There's no in between, right? You either have full read or nothing, right? Yeah. And everything is through hardware interfaces. So these are like, things like device I/O ports. It's, physically plugging in devices and stuff like that. Yeah. So operating systems can also run in virtual machines. I'm sure all of you guys have at some point in your life used a virtual machine at this point. I sure hope that you have if I guess you're mostly juniors, right? Yeah. Yeah. Okay, so we refer to the guest operating system or the operating system that's running in the virtual machine as a guest. So you might hear me say guest a few times. That's what I'm referring to. Yeah. So virtual machines differ from physical machines in a few important ways. They do not have full exclusive access to the hardware, right? That's the most important distinction, right? They do not also provide the OS with privileged access to the physical machine. So we'll get into like what that actually means. There's like some special instructions that you have to, handle in virtual machines. Okay, so to make virtual machines possible, we have to introduce a new layer in the operating system. We call this the hypervisor or the VMM. I think that your textbook calls it a VMM. I don't remember. But yeah, it's basically the system within the operating system that manages the virtual machines. Yeah, it's just a piece of software. There's nothing special about it. It just runs on the host. Yeah. And it can allow the operating system to run sort of like an application, right? Cool. All right, so this is what we're talking about here. This is the new thing that we're introducing. Up till now, this is like what your v6 looks like. It's just hardware, which is emulated, but whatever. Then there's the kernel, and then there's your processes. With the virtual machine setup, okay, you have multiple VMs that each run their own kernels, and then they each have their own processes, like fully separated, right? The VMM or the hypervisor is, in between, and yeah, the hardware is down here. Make sense to everybody? So why would you ever want to virtualize? It seems like a lot of extra steps. The main thing is it actually provides quite a bit of flexibility in the way that you can do things. One of the cool things that you can do with virtual machines that you just can't really do with physical hosts in the server world is you can migrate them between physical machines, right? That's a surprisingly useful thing to be able to do. Yeah. It can lead to better stability if you use them correctly. They do provide you with tools that make it so that you can set things up in such a way so that you can have multiple VMs that all make up one service, so that if one starts to crash, it doesn't affect anything else. We'll get more into what that actually means later. Yeah, it can provide more security. Again, if you use it correctly, it's the whole idea between virtual machines is that they're supposed to be isolated from one another. So if you have a virtual machine that's running a web server, then you can it won't be able to touch any data like on an email server, right? That's the main idea. It's kind of a waste to run an entire virtual machine for just a web server, but whatever. Yeah. Okay, some terminology. So the hypervisor is known as the host. That's generally just what you boot up into, right? The virtual machines are called guests. We already said that. Yeah, cool. All right, so there's a few approaches to virtualization. There's the main one, which is probably the easiest to understand and conceptualize. That's full virtualization. That's your VirtualBox or your VMware. That's where you're pretending you're virtualizing absolutely everything, right? There's no in between, right? Then there's what's called para-virtualization. This is pretty much what all of your hosting providers do, all your cloud providers, like AWS, DigitalOcean, Azure. They make small changes to the operating system to make it so that they will run better on their hardware, right? Yeah. And then there's the last one, which is my personal favorite, which is container virtualization, which we will be getting into in a great bit of detail later. Yeah. This is basically your Docker, your Containerd, your Podman, your Rocket, Run C. Yeah, there's a lot of different container solutions. See a question back there? Yeah, of course. Yeah, it's just being able to say you have a problem with the physical hardware, right? You see a drive failing or whatever, you can hopefully before the drive fails, right? You can export your VM in whatever form that your VM solution has that, and move it to a new machine, and then start it right back up as if nothing had actually changed. You just can't do that with physical machines, right? There's just more steps to do an equivalent maneuver, right? That's. I'm sorry, I can't. Well, yeah, it's not great. I have a huge bias. I like containers. Okay, we're gonna talk. The whole second half is about containers. We're just getting through what we have to here. Yeah. Okay. Yeah. Yeah.
Could you go one slide back?
One slide back. Yeah.
So for para-virtualization, I don't know if you said this and I missed it, but could you explain what small changes you might make? Could you give an example?
Well, yeah. Okay. So with things like EC2, they might, with Amazon EC2, have you used it before? Okay, maybe don't, because AWS is kind of, I don't know, I think it's bad. I don't like it. But they have an entire quota system for the CPU, where you have credits and stuff. They put stuff in the kernel, in the scheduler, to make it so that they can keep track of how much CPU you're actually using at any given time. That's one example. They might have extra things to work better with their storage. Storage in cloud is a ridiculously complex topic. I mean, it could be an entire 3-semester course, and you would barely even scratch the surface on all the different storage solutions. It would be totally valid to modify your operating system to work better with whatever storage solution your specific cloud provider has, right? If you cannot if you wanted to start a new AWS, a DigitalOcean, having trouble thinking of other ones, you would have to do stuff like this to really actually be competitive. Yeah, does that make sense?
That does.
Yeah. Cool. Any other questions before we move on? Okay, cool. All right, so there are sensitive instructions on CPUs. They were, for the most part, implemented back when the virtual machines just didn't really exist. But of course, as I'm probably sure that you guys have realized by now, there's a whole lot of backporting that happens with operating systems. Something that ran 80 years ago can still run on a normal CPU today. 80 years ago, in 1980 is what I meant to say. Yeah. These sensitive instructions have to be handled in some way, right? These are things like performing I/O, making memory mapping changes and stuff like that. You can't handle those directly, right? When the VM executes that instruction, it has to be handled in some way. Yeah. There's also privileged instructions, things that trap to kernel. Those have to be obviously handled in that specific way. You can't just trap to like the main host kernel and expect it to know what to do, right? Yeah. So there are these two famous computer scientists, Pokep and Goldberg, that wrote this important paper in virtual machine technology stuff world that said that unless your sensitive instructions are a subset of the privileged instructions, you cannot actually fully virtualize. Yeah, kind of interesting. Yeah, okay, so let's talk about x86. So there was a bunch of problems with virtualization up until 2005 when Intel introduced VTX. This is probably something that you may have interacted with before. Some laptops will have VTX turned off. I forgot what the AMD equivalent is called, but they'll have it turned off. I don't know why when you buy it, and then you just have to go into the BIOS and turn it on. Yeah. But yeah, that's what enables virtualization these days. Yeah. So VTX introduced new processor modes, root mode and non-root mode. So your VM runs in non-root mode, obviously. Yeah. So when the processor is running in non-root mode, sensitive instructions that cause a VM exit or a trap to the kernel get handled by the hypervisor. So we can see this sort of drawn out here. So first you have your privileged instruction, that's number one here. And then the next thing that happens is that you trap to the hypervisor, the VMM. And then you emulate the action in the VM, right? You fake it. And then you update the CPU with whatever values or whatever memory or whatever, and then you return back to the VM, right? So you're basically just faking it. That's what the point of it is. Yeah. Okay, so here's another example. This is that text is not super readable. You can do the same thing with devices. So a NIC is a network interface card. So you have like a NIC driver in your operating system, something that just makes it so that the networking is possible. When you need to actually go to network, make a request or whatever, the NIC driver will send a signal to the emulated device in the hypervisor. So that's just like a fake Ethernet plug is usually what it is. And then it goes to the actual NIC driver that's running on the hypervisor, one level up. And then it goes to the actual physical device, right? So you can see that there's layers, right? We're introducing new layers in the system. Yeah, different abstraction layers. Yeah, and then you can see your physical machine down there. Any questions about that? Yeah.
So where is the action actually performed? Like, is it at like every level?
It's every level, yeah.
Okay.
Does that seem wasteful to you? It seems wasteful to me. Like a lot of work, right?
Because the NIC driver and the application and hypervisor level it's like fake. It's not actually doing anything. What does it mean for them to perform the action?
Well, the whole point of virtual machines is that you don't give physical access to the machine, right? So there has to be some kind of abstraction layer there. For a NIC driver, I mean, I suppose most of them just forward whatever the packet is, probably. Yeah. Yep.
I think it depends on the hypervisor. For example, on Hyper-V, you can create a virtual switch, and that forwards it. Or you can do a host pass-through. That would like directly pass through.
Yeah, so the host pass-through, that's a good point that you brought up. So most VM solutions do give you the ability to pass hardware directly. Yeah. I think it's pretty much up to the hosting, the actual virtual machine software, like what actually happens in the background there. But yeah, I mean, you're running a kernel that does not have access to the physical machine, so you do need to have an emulated driver. That's just the reality, right? Make sense? Okay. All right. So I/O virtualization gets kind of difficult. Have you guys learned about direct memory access, DMA? No. Okay. Yeah, so it's kind of a broad term. It refers to a lot of different things, but in general, what it means is there are certain types of devices, especially today, graphics cards. That's great that you brought that up. that make it so that you can directly access the memory, the main board memory, from a device, be that a graphics card or whatever else, without going through the CPU, right? That's the important bit. That is very difficult to handle in a virtual machine. So yeah, you have to have like a remap thing in the hypervisor. It's just not quite as efficient when you're not doing like a direct pass through. Yeah. So in 2009, Intel added this thing, IOMMU, that makes it so that memory access like this can happen. Yeah. So interrupts from the device must also be remapped. That means you trap. You have to like emulate that action, and then yeah. Okay, so let's review. How did we create a virtual machine? We start with a physical machine, obviously. And then we create some software that's responsible for isolating that guest operating system from inside the VM. And then we use VM resources, like faked resources like memory, disk, networking, whatever, provided to the physical machine, but visible within the VM, but like sort of in a limited scope, right? There's one more. So what are the implications here? So VMs and physical machines share the same instruction set. Guest's OS can provide a completely different application binary interface, ABI, inside the VM. So what this means is that like you can run a Windows VM from Linux or a Linux VM from Windows. That's what that means. There's lots of challenges to get this to work because of privileged hardware instructions. Computers were just like not built with this in mind, so it had to be added later. Cool. All right, now we're going to get to the fun stuff, containers. Before I get into containers, who here has used a container before? I'm hoping to see a lot of hands here. Did you guys have to take the seminar class freshman year? What is it called? Intro to CS? Did they have you do that there? No? No. Okay. Yeah. Yeah.
Yeah, in mine, we used
In yours you did? Okay, yeah, cool. It absolutely should be covered there. It's a great technology. Okay, so how do we implement a virtual operating system in a container? You start with a real operating system. You create some software that's responsible for isolating the guest. And then, this software doesn't really exist in one specific form. We'll get into that a little bit. It's not like there's not exactly like a hypervisor equivalent, which makes it so that it's a little bit difficult to describe. But some of the tools that you would use is like run C. So run C is like what Docker uses in the background to like actually spawn containers. There's also Rocket, RKT, it's pronounced Rocket, LXC. LXC is like what everybody used before Docker came along, and then Docker. Cool. So container resources like processes, files, names, network sockets are provided by the real operating system, but the visibility outside is limited. That's same as virtual machines. So what are they exactly? Before we get into this, maybe I should describe. There's a bunch of great presentations from the people from the Docker Foundation, from the Moby Foundation that make Docker. They always say like the easiest way to think about like what containers are is think of it as a virtual machine, but then immediately stop thinking that because that's wrong and it's not correct at all. So what they are is they're sort of like chroot on steroids. Does anybody know what chroot is? Anybody used that command before? Okay, it's chroot. It's a way of changing the root of your file system. It's like that, but on steroids. It turns out that with chroot, you can get a decent amount of, you can fake a container like halfway with just chroot. So they implemented through user-level container engine runtimes. So not by the kernel itself. There's actually no reference in the Linux kernel anywhere about containers. It's just not there. The containers do not exist in the Linux kernel. What the kernel does is it provides the tools to create containers, and we'll get into what those two tools are, the two ones. So you probably already know Docker. Docker itself uses containerd in the background to actually manage the containers, and then run C to actually spawn the containers and stuff like that. So yeah, Docker is actually just it's basically just a very clean CLI and engine server that you can then interact with that actually uses a bunch of other stuff in the background to actually create the containers. So when you say a Docker container, you really mean a containerd container, most likely. It depends on your distribution and where you installed it from. Yeah. So there's also LXC and Rocket. Yeah, pronounced Rocket. Yeah. But those aren't nearly as popular. LXC was the first to come around, so you'll see like a lot of legacy systems. Like if anybody here goes to work for like, I don't know, I assume like banks and like hospitals are still using LXC if they do any kind of virtualization. You'll see that. Yeah. All right, so what are the implications? So the container and the OS share the same kernel. This is a massive departure from virtual machines. This is the main thing that sets it apart. So applications within and without the kernel must share the same ABI. So that means that you have to run, if you're running Linux, you can only run a Linux container. If you're running Windows, you can only run a Windows container. Don't run Windows containers. Yeah. There's a few challenges to get this to work, but the main thing that we use to do this is what's called operating system namespaces. So we'll get into that in a bit. Let's take a look at like what this looks like here. So this is with our virtualization. This is what we were talking about in the first half. This is, you can see that there's a lot more layers, right? I was saying it was kind of wasteful. This is what containers look like. You have one operating system, and then you have, using the tools that are given to us by Linux, you can separate them and make it so that they're sort of like separated. So yeah, that's nice. Obviously, you can see that there's a lot less going on here. There's a lot less to fake. Yeah. Okay. Can you run a Windows container on Linux? This is a question. Yes, no? Anybody feeling brave? I hear
Yes.
a no. Yes, you can run a Windows container on Linux? Okay. So it's actually not true. Because the container shares the same kernel, right? You would not be able to like actually emulate the actions. Now you could run a container that then runs like Vagrant or something that runs Windows. But that's sort of cheating. Yeah. Okay, you can run a Debian container from Arch Linux. Yes, you can. As long as the container uses the same kernel, it does not matter. Okay. So, does anybody know what the PS command is?
Process.
Yeah, it's a command in Unix world. I think it exists on FreeBSD and Mac as well.
Process shell.
Yeah. It lists the processes that are currently running on your machine. So yeah, when you're inside the container, if you try to list the processes, it will only show the processes that are actually in the container. It won't show what's outside of the container, right? But if you run PS from within your host, so outside of the container, it will actually show the processes that are in the container as well as everything else. Yeah, we'll get into that a little bit more later. Okay, so why would you use containers at all? It shares many, but not all of the benefits of like full hardware virtualization. The main difference is that there's just like way less overhead. There's just a lot less to fake in the layers. Yeah, you can package a program or a service into something that actually runs basically the same on any host. Obviously, that's not always exactly how it works in reality, but yeah. You can adjust the limits of for what that container can use based on the system's needs. That's always a nice thing to have. So, if you have a web server, you can limit it to 500 megabytes of memory or whatever. That's a thought for a web server, but whatever. Yeah. Oh. And you can split up a system into microservices. I'm wondering who here has heard of microservices before? Yep. It's kind of a buzzword, but it does have a real definition. It's one of those words that like the marketing people at tech companies like grab onto, microservices. Yeah, I guess it was actually sort of in the news semi-recently because Elon Musk pretended to know what microservices were and didn't do a good job of pretending. Yeah, when he like started just like having Twitter shut off like the microservices for like SSO, so like people couldn't like do 2FA, so LOL, yeah. The idea behind microservices is, well, we'll get into it later. Let's just leave it for that now. Yeah, but then you can use these cool things called container networking interfaces. Again, networking in cloud is, gets really complicated, and we could have an entire course on it. But the general term is CNI, container networking interface, that lets you connect containers to another. So like the same way that you described with virtual machines, where you can have like a hub and spoke type thing, you can do the exact same thing with containers. Yep. Okay. Again, isolation, that's one of the big reasons for why you want to virtualize in the first place. another thing is that containers should not leak information inside or outside the container, right? That's pretty important, especially if you consider something like Anubis. Okay, how bad would it be if, like, during the midterm you could see somebody else's IDE? That would be pretty bad. It happened. There was a networking bug. I actually have a blog post on it, but that happened 3 semesters ago or something, where somebody clicked go to IDE and they went to somebody else's IDE. So a little yikes there.
Cache one?
Yeah, it's the cache one. Did you read that?
Yeah, I read the blog.
The book?
The blog.
Oh, the blog. Yeah. Yeah, you can read that. It's on the blog. Yeah. Okay, so yeah, and you can isolate all of the configuration and software dependencies for that specific application within the container. I mean, you can do the same thing with virtual machines as well, but this is part of the philosophy, right? Is that you can have a container that's a fully insulated service. Yeah. Okay. Yeah. So let's talk about what happens when you make like a system call, yeah.
So if you choose to use a container rather than a virtual machine for the less overhead, what are the things you lose? What can a virtual machine do that a container can't?
Let me. The answer to that is a few slides down.
Okay.
So yeah, I'll circle back to you when we get there. Yeah. Let's talk about what happens when a trap happens when you're in a container. The container makes the system call. Where does it go? It traps directly to the host OS. There's no hypervisor here in between. Now, it's up to the kernel to consider and to do the right thing here, right? That's really the only thing that you need to actually have containers, is just to make it so that the kernel considers where things, what things that process should be able to touch, right? That's basically all that you need. We do this with what's called resource namespacing, so we'll get a little bit more into that. To answer your question, on Linux, it turns out that you are actually always in a container. It's just that the container that you start with has absolutely no limits, and it can see everything, right? That's one of the things that makes it so powerful. It's you start in a container. Yeah. So if you think that you're getting a performance benefit by not using containers, I have to explain this sometimes at work, but with you will too. Some people, that didn't learn how to do programming when containers existed, when they started to become really popular in around 2015. If you were not learning about it at that time, you might think that containers are some kind of a performance they take a performance hit the same way the virtual machines do. They just don't. They're treated basically as if you're running it on the direct hardware. Yeah. Any questions about that? Does that make sense?
So why would you ever use a virtual machine?
That's a great question. That's a really great question. Why would you ever use a virtual machine? The answer is you usually don't actually need to. It makes a lot of sense for hosting providers, like for your AWSs, your DigitalOceans, your Azures, right? Because when you click a button to say, can I get an EC2 instance? Can I get DigitalOcean calls them droplets? Then yeah, a virtual machine makes a ton of sense there. It doesn't make any sense to give them a physical, a client, a physical machine. But then once you're on there, does it actually make sense to run an Nginx web server with a virtual machine? No, of course not. Why would you do that? Containers are the solution. Yeah. There's a tool that I'm going to talk about later that is sort of an interesting mesh between containers and virtual machines. Yeah. Okay, so let's talk about namespacing. So this is the main tool that you need. This is basically the only thing that you actually need to implement containers. It's a concept of that when you're in a container, the runtime creates a set of namespaces for that container. The namespaces are, they provide a layer of isolation, right? They limit what you can see, what you can affect, what you can use. It basically just puts you in a, not to be pedantic, but a container. Yeah. It's implemented within the kernel, so this means that Linux has to handle the namespacing. This is the tool that Linux gives us to make containers possible. Every type of resource, there are multiple types of resources that have different namespaces. Yep, so for example, PID namespaces, process ID namespaces, net for network interfaces, MNT, that's your mounts, so your physical drives and stuff. UTS, which is Unix time sharing, it's host name and time. You can also do IPC. Does anybody know what IPC is? Wondering. It used to be the cool kid on the block 5 to 10 years ago, and now nobody uses it. It stands for inter-process communication. If you take Unix with Sterling, he teaches you how to use this. It's like you can use like shared memory and stuff between processes. Yeah, it's kind of difficult to do correctly, so not many people use it anymore. Yeah. There's also user namespacing. So this is where like you can pretend to be another user in a namespace. I'm going to talk about how we use that in Anubis to do something kind of cool later. Okay, so the example resource that I'm going to be talking about today is going to be PID namespacing. So I did not get confirmation from Gustavo on this, but you might, the next homework assignment, it might be the last homework assignment, don't quote me on that, might be a container assignment. So yeah, I wrote the assignment like a few semesters ago when I was still a TA. But yeah, it's basically to implement PID namespacing within XV6. Yeah, I chose PIDs because they're probably the easiest to understand. They're the simplest to understand. So yeah, we're going to be talking about PIDs. On GNU Linux, there's this special place called /proc. /proc is a special mounted file system that allows you to query for information from the kernel. So if you do /proc/self, that gives you a directory that has a bunch of files in it. Those files, if you try to like read or write to them, it will tell you about your current process. So if you list the directory for proc/self/ns for namespace, it will tell you what namespaces you're in. And because in Linux everything is a file, it represents them as a file, right? And you can see here that all of the numbers there represent the actual namespace that you're in. Yeah. So yeah, feel free to go ahead and try that. Yeah. Okay. So when you're doing PID namespacing, the PID namespace that you're in can only see the processes that are within that namespace, within that same PID namespace. Each PID namespace should start with 1. That means that like the first process should be PID equals 1. Yeah, and then if PID1 exits, the whole namespace should be killed. I think it's up to your runtime, your container runtime, to actually do that, but yeah. Yeah, like in Docker, if PID1 exits, it will close everything. Yeah, so namespaces could be nested, so that means you can start a namespace. You start with your root namespace, your root PID namespace. You can open a new namespace for PIDs and then do that again, and then at each level you can see the levels below you, but you can't see up. Does that make sense? Yeah. Okay. Yeah, so the process ends up having different PIDs depending on where you look at it. Yeah, I'm not going to ask you to do that in XV6, but yeah. Okay, so what happens when you run PS in a container? So let's take a look at what this command is. We're just doing docker run alpine, which is just a lightweight Linux distribution, PS, and then with some options, it will tell you that you have, that your PID is 1, and that the only process that's there is the actual one that's listing the processes. Make sense? So this is exactly what we want to see. If we saw like all of the processes that were running on this machine at this time, that would mean that we did not properly do a namespace, PID namespace isolation. Make sense? Yep. See a question?
My understanding is that these namespaces are the libraries that containers use to virtualize.
Well, they're not libraries. I wouldn't call them libraries. They're an interface provided by the Linux kernel.
I mean, so it's using the same C files as but any other Linux, like as a Linux kernel.
It's using the same C files. I'm not sure I understand what you mean by that.
Is it running? I mean, this PS. I'm trying to understand how you virtualize from that perspective.
Well, it's just Docker. I mean, what do you mean by that?
I didn't really understand what a namespace.
Oh, yeah, I see. Have you written C++ before?
I've worked it. I know I've done C++, but I didn't understand why you called it GID namespacing.
Oh yeah, let me go back a few slides. So there are different namespaces, or where's that? There are different types of namespaces based on the type of resource that you're talking about. So I'm only going to be referring to PID namespaces because I think that they're the easiest to understand. Yeah, does that make sense? Yeah, okay. It's basically just a number that's assigned to your actual process that says like that everything in that namespace is like isolated from everything else, right? I mean, does that make sense? Yeah, another question? The user namespace?
Which namespace have you been working with?
Well, XP6 doesn't implement namespacing, but if you're on Linux, when you start it up, it's just basically you just start in with some namespace, right? Like okay, like here, if I open up a terminal here and can I bump the text size up? I cannot bump the text size up. If I do like ls/self or proc self and s here, then I'm not in a container here. This is just like on the host, but you can still see that like I do have an actual namespace values for everything here. That is like, that's just the reality on Linux. Like it's just part of modern kernels. Like you just always are in a namespace. Just the one that you start with has access to everything. Make sense? So then when you create new namespaces for like a container, say, you can start that namespace and then take away access to things, and then you won't be able to see anything outside of that.
And
That's the goal, yeah. Okay. Okay. All right, let's continue. Yeah. Okay, so let's talk about net namespaces for a moment. So the typical use case is that you want to have a virtual Ethernet adapter that acts as like a crossover cable, so kind of like the hub and spoke thing that we were talking about earlier. This is like maybe some kind of a arrangement that might make sense. The Docker gives you the ability to do --net host, which makes it so that you share localhost with your actual machine. Yeah, that makes it so that animations are out of whack here. Yeah, that's not on the right side. The net namespacing, being able to like actually mess with the network interfaces, is where things get really powerful. It makes it so that you can abstract things to a higher level and make it so that you can actually like do networking between machines and between containers. Yeah, stuff gets really interesting here. Yeah. All right. So you can create a virtual interface that has its own network. You can use the net namespace to put multiple containers in there, and then you can have multiple Docker containers connect to each other. So you can kind of have like a nice little cluster there. Yeah. Makes sense to everybody? Yeah.
I had a question about the run command for Docker.
Yeah, which one?
Yeah, so that the run, that creates a process, and that process is...
Well, it creates a container, yeah? And then there's a process in the container. Yeah. Okay. All right. So the second thing is C groups. So C groups stands for control groups. I think that this has been a question on the midterm for the last few semesters, actually. It stands for control groups. It does not stand for container groups. Do not guess that. So yeah, it's implemented within the kernel. Yeah, it limits what resources you are allowed to use. So specifically, like the most common ones are like CPU and memory. So this is basically a way of making it so that your containers can only use some specific amount of CPU and memory, which in like a production cluster is extremely important to do, actually. You cannot have one row container that has whatever going on inside of it take over all the memory and stuff and make other stuff kick other stuff off. That's not an acceptable thing to happen in production. So yeah, it's entirely up to your container engine whether or not they handle C groups. Yeah, it's not actually a default that C groups will be there. Yeah. So CPU C groups keeps track of user and system time in the CPU, and then it allows the CPU to set weights. It allows you to set weights for like how much CPU you're actually allowed to use. With things like variations in like core clock speeds, instruction time execution, there's not actually like 100% precise way to limit CPU. It just doesn't actually make sense to do that. Like there's just too much happening in the real world with CPUs. But yeah, it lets you limit it, sort of, approximately, right? Yeah. A cool tool that you can use on Linux is systemd cgroup top, which is, well, assuming that you're running on a systemd system. If you're not, come talk to me after because you're cooler than me. Yeah. And you can see like all the weights and how much CPU things are using. Yeah. Okay. Yeah, there's not that much that you actually need to know about C groups. But yeah, there's a ton of very cool things that you can do with containers. Here are a few of them. One of my favorite things that I recently learned about is this thing called Linux Kit. It basically lets you build virtual machines that run only containers. So there's no it's basically just the kernel and like containerd that runs and then the containers that run. It makes it so that you can build full virtual machines on any platform. So like on AWS, on Azure, you can make them for QEMU images. You can make ISOs, like bootable ISOs and stuff like that, that are insanely lightweight and insanely fast to like build into boot. Because it basically, like, if your virtual machine only runs containers, like, there's no reason not to use Linux Kit, because it removes everything in between the kernel and the actual container, and it's just those. It's actually really great. There's a whole field for storage drivers, so like how do you make storage happen in containers? It's actually like ridiculously cool. I wish that we had time to talk about it. The way that storage works in Docker, it's actually kind of a modern like engineering miracle that it works as well as it does. Overlay networks, which is the way that Docker works. Container registries. There's SE Linux and capabilities for securing things. We use this a ton with in Anubis. I have an entire other presentation you can look at if you're interested in that. We have also rootless Docker that runs in Anubis IDEs now. We'll get into that later. There's a ton of security implications with containers. It's really easy to do the wrong thing. Just the same thing as everything basically. All right, so here's my one meme for the lecture. There's Docker on Linux. It runs really, really great. And then Docker on Mac, where it's just a complete hack. And then Docker on Windows, where it's absolutely terrible. I'm wondering, who here runs Docker not on Linux? Yeah? Do you guys think I'm crazy for saying that it runs so well?
Yes.
Yes? You want to know why? I took that slide out. Docker on Mac and on Windows does not actually run on the host because there's no reason for them not to, but Mac and Windows do not provide namespacing or C groups. So what that means is that Docker on Mac and Windows actually runs in a virtual machine. Yeah, it's actually the main thing that Linux Kit is used for, is to make the Docker desktop. So like Docker desktop does not exist on Linux. They recently added it, and I think it's a huge mistake. They try to trick you into installing it now. Don't do it. Cool. All right, let's talk about where containers run. So LXC is the initial one that released in about 2008. It's still used in some legacy places. Most people have moved on since then. They're a lot less lightweight than like Docker, like Containerd. There's a lot more to them. There have been many more container engines and runtimes that have come about, but I mean the main ones are Containerd, which is what Docker uses. Another popular one is Podman. Podman is like the whole idea behind it is it's like always rootless, and I don't think it even has an engine. Like it doesn't run a server. They all revolve around Linux, and that's because Windows has added Windows containers, but they're absolutely awful. Like the Windows base images are like 16 gigs. Like you end up spending like more time waiting for the Windows base image to download than it takes to just like fully deploy a Linux container. So it's kind of useless. Okay, so we were talking about Mac OS and Windows. It doesn't. It runs it in a virtual machine, which makes it so that's why you have to like give Docker in the GUI. You have to like say like how much CPU and memory to give it. I mean that's because it's a virtual machine. You have to say how much memory to give it, right? That just doesn't exist in the Linux world, right?
I also noticed that if you want Docker on a Mac OS or Windows, you have to enable VTX.
Yeah, that's why. It's because it's a virtual machine. So the result of this is that networking and volumes are particularly like unreliable on Mac. So I don't know what you guys will be doing after you graduate from here. But if you end up going to work for a company that uses Mac OS, you might be having to explain to people that when this actually reaches production, then it might not be so bad. Cool. I understand if you hate it. Give it a try on Linux. It's a lot better. They all come from this thing called Docker Desktop, which is not made by the same people that make Docker. It runs like a dream on Linux. There's barely any overhead to it. It's really, really nice. Okay, now we're going to talk about the really interesting stuff. This is where the content for your actual course ends, and we're going to be talking about some more like interesting concepts that don't apply directly to operating systems, but this is where it gets more interesting. So we're going to be talking about the cloud. So with the resurgence of virtualization, it has been very popular to talk about the cloud. Again, this is one of those buzzwords that marketing people grab onto. It's a little bit of a nebulous concept, but it traces back to like old networking diagrams. If you're wondering like where that word comes from, yeah, it's like basically like people like us would have to go into a boardroom to get approval for funding or whatever, and instead of actually drawing out what their networking diagrams look like, they would just draw a little cloud, and that's where it comes from. Yeah, nice little history lesson there. In reality, what the cloud refers to is a large number of physical servers that are rented out as virtual machines for various services, right? So the idea is that you can get an account with like AWS or Azure or whatever, and then you can just click a few buttons and you can get your servers that are themselves virtual machines to access and do your work on. Yeah. So clients are granted access to a full virtual machine. In what form that comes in is up to your hosting provider, though. Yeah, the billing works by based on how much resources you use. So basically, every hosting provider does it a little bit different. It turns out that it's actually somewhat. Some of the hosting providers are a little bit misleading about how much stuff costs, as I'm sure that you guys have probably found out. Some places like Azure and AWS are kind of ridiculously expensive, where other places like where we host Anubis on this service provider called DigitalOcean. They're actually upfront about their pricing, so you can actually predict like very accurately how much things are going to cost, and it's way less than AWS, I'll tell you that. Yeah. So the important thing about the cloud is that everything happens without human interaction. That means that you can just click a button or through some programming call, literally what I just did when I had to open the terminal here. I just scaled the Anubis cluster by running a single command. I've made it so that there's now 35 machines that are getting added to the cluster right now. Yeah. Yeah. The important thing is that you need to be able to actually scale and respond to the changes on demand. That's a very important thing in modern applications. In reality, you'll find that most applications don't actually need a ton of servers 24 hours a day, especially if you're running a service that's used by humans, right? That means that you basically need to acquire the compute when you actually need it, which is usually, for Anubis at least, it's when there's a deadline, or like an hour from now, Jeffrey Epstein's seminar lecture on I forget what the course code is, but they're getting on, and there are going to be like 200 people, so that's why that's why there's that many machines being added. Okay, let's talk about Kubernetes. I'm wondering who here has heard of Kubernetes? Yeah, a few. Okay, who here has used Kubernetes? Oh, we got one cool kid. All right.
I built my own Kubernetes.
You what?
I built my own Kubernetes.
You built your own, really?
Yep.
Here at NYU?
Yep.
Like
I
you?
have my own servers at NYU.
Yeah, but why would you do? Did you do it like did you use like
I use Rancher.
Rancher? Yeah, okay. It's not that bad on Rancher. Have you ever tried to do it like without Rancher?
Yes, and it was an absolute.
It was an absolute mess. Yeah. Okay. Well, so let's talk about what Kubernetes is. Kubernetes is what's called a container orchestration tool. So it's a higher level concept that allows you to have a lot of different servers that run containers and interacts seamlessly between them. That's the whole point of it. You might hear me refer to it as K8s. The 8 in the stands for the number of letters between K and S in Kubernetes. Now you're one of the cool kids, and you can use that at parties or whatever. Kubernetes allows for things like container networking interfaces, which I alluded to earlier, and container CSIs, container storage interfaces, to go from just being on one single machine to being applied to a whole lot of machines, right? Yeah. This allows us to, in theory, design and implement very large systems that rely on many individual containers commuting at once, and most importantly, in a very abstract way. Like when you ask Kubernetes to do things, you basically say, I just want a service, this is what it looks like, here you go, and then it will figure out where to put it, and it will figure out how to get those resources, if it's CPU, if it's storage or whatever, and it will just do all of that for you. It's actually quite nice. It is very much an advanced tool, though. It's definitely, if you're just running a web server, again, we're on the other end. It's way too much. Yeah. Okay, so we're going to mention a Kubernetes pod. It's basically a single unit of work in Kubernetes. It's an abstraction that's one level higher than a container. So a pod can actually contain multiple containers, but it also includes things like volumes. So like if there's any storage being attached, config maps, which are like a way of defining configuration, You can also have secrets, which is obviously a way of like passing in credentials or whatever. Yeah, they are designed to easily share resources between the containers within that pod. It's a very important thing for our Anubis actually. So here's a very simple example. It would be very nice if you didn't have to restart a web server to get the latest HTML, right? So what some services will do is they will have the actual web server and what's called a file puller as two separate containers that run in a pod with a shared volume in between them with all of your data, right? The file puller will always just constantly be checking and polling for the latest changes to your HTML, and then your web server will just automatically be up to date. In theory, you could put those in the same container, but it's nice to be able to separate them like that. And because they're so lightweight, it makes it so that that's actually a very easy thing to do.
Isn't that actually highly inefficient? You could do something like CI/CD or to like build it, then deploy it. Maybe, for example, when you're doing an update, you can like uncode it or like drain the nodes and like do the other.
Yeah, and that's what we do in Anubis. Yeah, yeah. This works for specific. I mean, this isn't like the only way to do things. It's just something cool that you can do. Another very common thing is that you will have a logging container sitting next to your like main container that its only purpose is to just like grab logs and export them to wherever else. So then like your actual application doesn't necessarily have to actually like deal with exporting the logs, right? You can just leave that to your they're called sidecar containers to handle that. It's kind of like, well, okay, daemon set's completely different. We can't get into the Kubernetes stuff because, yeah, again, that's what I would like the class to be. But yeah, all right, here's a picture of like what a container, a Kubernetes might look like. The top level thing is you have what's called a node agent. It's just the actual thing that runs on the server. And then you have what's called a container resource interface plugin. This is what actually interfaces with whatever your container runtime is. On Kubernetes, it's basically always going to be containerd. I don't even know if you can change that, but that's the interface in between the things. And then yeah, containerd that then creates the pods. So Kubernetes has a record of everything that happens. It figures out where things should be. It uses the CRI plugin to interface with containerd. Containerd then creates our containers. It does all of our namespacing for us. It does all of our C groups for us, and it will share whatever resources we tell it to. Does that make sense to everybody? It's a little bit of this is a little bit of an abstract concept. Any questions before we move on to Anubis? Nope. Okay. Cool. All right. So Anubis is a very large system that's split up into a bunch of microservices. So I alluded to this earlier, but what a microservice is it's a model of splitting up a very large system into a lot of different pieces that all interact with each other. They're all each of them is responsible for some specific thing, right? Yeah. So here's the most basic example. We have a service that just handles the HTML and JavaScript serving. So when you load a web page, right, you hit our web static service that itself is made up of a few containers. And then we have a separate service that's a Python Flask API that handles the actual, like when you click a button, you say, I want a container, it will spawn, you'll interface with that Flask server. Does that make sense? How we split that up? I see. Do you have a question?
Why Flask?
Why Flask? It's because what I knew at the time.
Fast API, where you can do like asynchronous.
The Fast API ecosystem I have found is actually extremely lacking. It's great if you need to write something small for Fast API, but if you need like anything that has to do with like caching or like databases, if you're using Fast API like the async stuff, it's actually like kind of a mess. Yeah, the caching thing is the big reason why we did not. I was considering at some point switching to Fast API, but it's very difficult to do things correctly in Fast API. It's not quite as mature of an ecosystem, even though the Fast API itself is a much better complete package. That's why we didn't use it.
Flask handles caches by itself.
Well, they have third-party libraries that actually handle that stuff for you, that are mature and that a lot of people use. There are libraries for Fast API that do caching in the same way. It's just way less people use them, and yeah, I mean, I wouldn't want to rely on them. That's the bottom line. You basically also, if you're doing anything async, you basically have to rewrite the entire library, which is not fun. Also, the Flask SQL Alchemy is an incredible library that makes it so that interacting with your database is like super easy to do in like a multi-threaded way. Yeah, you would have to completely rewrite that. I'm amazed that nobody has rewritten that. I tried to do it once, but it's actually kind of bad. It's kind of difficult to do that with the Python async stuff. Okay, so within any of these services, there might be multiple containers, each of them doing a specific task. Yeah. Any questions about this before we move on? Okay, cool. All right, so at any given time, there might be 1,000 plus containers running. That's sort of a lowball estimate, actually. Yeah, so the last time that I did this lecture, I checked for like one day, we had 535 IDEs on that single day. We had a day earlier this semester that had, what was it? We had 250 people on at one moment, like actively in an IDE. Yeah, I mean, we must have gone through thousands of containers in that day. But yeah, the main idea behind that is like, you can when you split up things into lots of different containers, and then a lot of people actually use your thing the same way that Anubis does, you end up with tons and tons of containers. Now, because of there's very limited overhead, that's not actually that big of a deal, right? It's basically just individual processes. Make sense? All right, so I just want to throw this up. Don't worry about reading this or anything. I know that this is unreadable. I just want to show you that this is what an earlier version of the Anubis system looks like. There's like 10 more things now than this, but yeah, just want to show you how complex the system is. Yeah. All right, let's talk about the Anubis IDEs. So the IDEs are made up of individual containers. And every single one, they have a separate environment and file system from each other. That's a pretty important thing to be able to do. When you're talking about, student environments, it's not a good thing if those student environments can mix. Yeah. All of the IDEs have CPU and memory limits that are handled by the C groups stuff that we talked about earlier. There's a whole other set. I have a whole other presentation that's just about how we box students in using all of the tools that containers give us to make it so that it's very difficult for you guys to like mess with each other in the IDEs, basically. Yeah. So any Anubis Cloud IDE might have 3+ containers at any given time. The lowest that you can get is 3 containers. So the first thing is what's called an init container. That's the thing that actually clones your repo or fixes any like file system permission issues. That runs first. And then there's the actual IDE server. It's just code server. It's a pretty common tool that people use. I think it's actually what what's the other one? Gitpod uses, I think, the same like backend for the VS Code server. And then we have the autosave sidecar, which I'm sure that you guys are quite familiar with. Again, sidecar is just a container that sits beside your main container, which is our IDE server. Any questions about this? You might be wondering why the autosave is in a separate container. It's because there's credentials in it, and it would really not be good if we put those credentials in an environment that students were able to access. That's not a good thing. Yeah.
What makes like a sidecar different from just having multiple containers, if that makes sense?
What? Oh, it's sidecar is just a term to refer to like like not your main container.
Oh, I see.
Yeah, it's Kubernetes doesn't even have a concept of sidecar. It just means that's it's not the main container. It's something that assists the main container. Yeah. So all of the containers work together to make the cloud IDEs possible. This is what your IDEs for when you're doing your homework assignments will look like. You'll have your init container. You have a volume that's shared in between of all of them. So it's just like a little file system. It's like a little, you plug in a little USB stick. You can think about it like that. That has all of your files for the session. So this is how we can have separate containers that interact with each other. Is the /home/Anubis is mounted in each of them. So, you make a change in your IDE server, the autosave sees it in the same place. Does that make sense? Yeah. It's like it's mounted over a network share, so I mean you can think about it like that. Something kind of interesting that Kubernetes does is they actually share the localhost networking interface. This is a really difficult thing to maybe understand. It's a little bit of a abstract concept, but that makes it so that if in the IDE server we listen on a port, we can actually connect to it from the sidecar. Does that make sense? This is actually how the sidecar sort of works. I'm wondering, has anybody ever typed Anubis autosave into their IDEs? Yeah, a few people. So that triggers an autosave. what it actually does is there's actually a Flask server that runs in the sidecar that listens on, and I think it's like 5001. So when you type in Anubis autosave, what it actually does is it makes an HTTP request over to the sidecar, and then tells the sidecar, hey, I want to do an autosave, and it will run that thing. Does that make sense? It's kind of just a nice little container trick that we can do to make things happen. Yeah. Okay. Yeah, so all of the containers work together to make the IDEs possible. It's the core concept here is breaking up responsibilities. It turns out that when you do stuff like this, you can make it so that your systems have certain assurances that you wouldn't be able to otherwise, right? Easiest way to think about this is, have you guys learned about what ooming is out of memory? Has that come up yet? Okay. In Linux, there's this concept of ooming, or running out of memory, or out of memory, where your physical machine runs out of memory, and then what happens in most Linux is what's called the killer will come and just like start killing processes so that you can get your memory back. This is something that's potentially dangerous. It means that you wouldn't want your killer to kill your database, right? You would want it to do something else. With containers in C groups, it allows you to limit things to say like, this is not as important. You can't use, you can only use this much memory, and it makes it so that you don't have to quite worry about ooming so much. So, an individual component can start acting up without it affecting everything else, right? Does that make sense? It's just a very nice design thing that you can do with IDEs. So something very interesting that I've recently added to Anubis. This isn't in your homework IDEs, but this is in the playground IDEs. I've added a Docker sidecar container to the IDEs. So as it turns out, you can run Docker in Docker, and that's what I do here. Yeah, because it's just nested namespaces. So as long as you set things up correctly and you have the proper libraries installed, there's no reason at all why you can't run Docker in Docker. Yeah, okay. Did I hear a what over here? It's kind of a cool thing that you can do. Yeah, so if you open a Playground IDE and you type in like Docker PS, and you can see here that it's running there. Yeah, just kind of an interesting thing that you can do with containers. There's, in addition to this, there's actually I wrote a Docker authorization plugin that makes it so that like certain commands won't go through if you type them, because it turns out that like Docker is kind of like an all or nothing type of tool when it comes to permissions, and for various reasons that we don't really have time to get into, it's very easy to spawn a container that like will be able to like get a container escape, get out of that container, access the physical host. I've written an authorization plugin to make it so that hopefully it won't happen, but yeah, we'll see. Cool. Okay, so now it's time for a demo. I personally am, you guys can choose what you want to see, but I am personally leaning towards taking a look at the container security stuff. I also have a demo for how you can create a raw container on the command line. Anybody feel partial to one way or the other? Yeah. You want to see me create a container? Anybody else want to? Yeah.
Yeah.
Same thing? Okay, yeah, we'll do that. How am I doing on time, by the way? Okay. Man, every time I do a lecture, I get like 1,000 LinkedIn requests. Okay. Here.
Just to see, Anubis is running on its own servers on NYU, is that correct?
It does not run on NYU servers. It used to run on NYU servers. So actually, it's interesting that you mentioned Rancher earlier, because Anubis itself used to run on Osiris Lab servers here at NYU. And when I set it up so that it would run on a Rancher setup that was like totally self-hosted and everything. It was fine when we had like 100 students on there. It would be, it's without a proper hosting provider, when you're like running your own hardware, it would be very hard to like handle the amount of students that we currently have that use it at any given time. Yeah, like you can't just add new servers. You can't just scale quite as easy, right? Yeah.
Anubis is only for NYU students, I guess.
Yeah, for now. Anybody at the university can sign into it though and launch an IDE. So like one of the things that we've been trying to do is see if people at CAS would like to use it, but we have this problem where every time we send an email to somebody in NYU leadership, they think that we're trying to sell them something. So we're it's it's already funded by the CS department. Like they already pay for this and everything. Anybody at the university can just sign in, click a button, and get a Linux environment, right? But yeah, so yeah.
How much does like the like using the server cost for Anubis like per month?
Per student, I have not checked in like a few months. It's definitely more. Or the thing about the server costs when it comes to Anubis is actually like there's a I'm forgetting my finance concepts. There's a certain amount of cost that just comes with running the cluster, and then the more students you add, the less it costs per student. There's a VM solution that used to, well, I think it still runs here. We were about like, I think it was something like 60 cents a month per student. It's pretty cheap. I don't quote me on that. I would need to check. At one point, it was like around 60 cents per student, which is way. It was like we did calculations for like what the other solution was using, like the one that did like full virtualization and like self-hosted hardware and stuff like that, and it was closer to like $60 per student. So, yeah, it's a lot better. Don't call me on those numbers. I did those calculations like 2 years ago. Yeah. Okay. Cool. Let's do our demo here. I need to this presentations. Just need to grab my demo. Is this readable? Is this okay? Let me open it in Emacs here. It's not that much better. Hold on. Is this better for everybody? Yeah, okay, cool. Everybody in the back can see? Yeah. A what? Sorry, No, this is just my laptop. Oh no, I mean you can do that if you want. There's nothing. Yeah. I mean you wouldn't be able to do this demo specifically because you don't have root in that, but this is just yeah. Okay. So first thing that we need to do is just adjust our path here because this gets messed up if you don't do this. Let's go ahead and paste that in there. All right, so the first thing that you got to do is run this command. You're probably going to see quite a few commands that you might not have seen before. I'll try to explain them as I go along, but yeah, if I'm doing anything that you don't understand, like please stop me and ask a question, because otherwise you probably won't understand what's happening next. The first thing that we have to do is run this mount command. This mount command is makes things private. This is something that you just need to do for like the mount namespacing to work, which we'll use later. Yeah, okay, so then we can go ahead and cd to our /mnt. mnt is just a special directory on this, yeah, let me bump up the size a bit more here. Yeah, okay. /mnt is just a special directory on Unix systems. It's just generally where you mount things. Yeah, mnt is short for mount. Okay, so the next thing that I'm going to do is grab a Alpine container from Docker. The reason why we're doing this at all is so that I can just basically grab a Linux file system that we can then use as a container, right? All right, and then I'm running this command right here, which will, if I now do ls in here, we can see that like we're in /mnt, but I just exported that Alpine image to a file system basically. So this is just a nice and easy way to get like a full clean file system. Yeah. Okay, now the next thing that I'm going to do is just for all of our sanity, I'm going to make a file here this is a container. So now when we have achieved the full container, we'll actually be able to verify that, right? We'll, ls/ and we'll see this is a container. Okay, so now the next thing that we got to do is actually shroot again, chroot is chroot. That's not the right directory there. We're going to change root into /mnt/binsh. That means that we're going to change the root of the file system for this particular process, and we're going to run sh. That's what that means. So when we do that, then we can do ls here. We can see this is the container. We can see that this is the root. Are we in a container here? Not yet. We just pivoted the root, basically. There's nothing fancy that happened there. So to actually do the namespacing stuff, there is this special command on Linux that's called unshare. Okay, this unshare does kind of what it sounds like. It lets you, run for all the different types that you want. So like we're doing mount UTS, Unix time sharing, IPC, interprocess communication, net, and PID, and fork namespacing here. And then, okay, it looks like nothing happened, right? But if we do, we actually are technically in a namespace container. It's not a full container, right? Because we haven't, there's stuff that you have to do afterwards that we're going to do to make it so that like you actually can't see things. But this is the first step, right? We have separated the namespace. Next thing we got to do is remove access from things. Does this make sense to everybody? Questions? Okay, cool. Yeah. That's what the unshare command does. It's a way of maybe I could show it this way. Okay. So I just closed that process. So we're back at the host, right? If I do ls proc, actually no, that won't work. Yeah, you just trust me. We have separated the namespacing on these resources here for this shell. Yeah. Okay. All right. So the first thing that we can do is change the host name. So we can do caps lock host name container. So we can see that right now it's my Vola Dynamics XPS machine here. So now if we do exec bash here again, we can see that my host has changed to container. That's cool. Now if we do ps aux here, I bet you you wouldn't be able to guess that you can actually still see everything. Sorry, this is a little bit cut off. I can't fit that much text on here, but you can still see everything from outside of the container, right? This doesn't seem right. We did PID namespacing, right? Well, as it turns out, the PS itself doesn't read the namespaces. It actually gets all of its stuff from /proc. And the /proc that we have here is the same /proc that we had before we did the unshare. So the way that you do this, the way that you fix this is you basically just go and you run a mount, you mount a new /proc. So now if we do ps aux, now there's way less stuff. There's just the bash shell, the actual shell that we have here, and the ps aux. Does that make sense? So we just created the new proc namespace, or the new /proc. Okay, now this doesn't always work, but we're going to try to do what's called a pivot root. It's a very similar thing to shroot. It does exactly what it sounds like. It just makes it so that you can have two root file systems and switch them around, basically. Yeah, so the first thing that you need to do is make a place to put the old root. So we call that old root. And then we can do pivot root here. Let's see if this works. It doesn't always work. Yeah, this might not work. Whoops. Yeah, okay. We'll ignore that for now. But yeah, if we run the mount command, we can see that there's still like a ton of actual we can still see everything that was mounted before. So this might include things like we can see here, this is my NVMe stuff. Like the container shouldn't have access to that. So yeah, the way that you do that is you do umount a. This will unmount everything that it can. So if we run mount again, we can see that there's a lot less stuff here. That one that I pointed out, the NVMe, the actual physical storage device on here, wasn't mounted. Now when you do that, it just unmounted the /proc that we did. So we just run that one more time to get our /proc back. Let's see here. There we go. Now we have a /proc again. So we do ps aux. We can see that, yeah, everything that's there is supposed to be there. Yep. And then we can do, so now we're basically isolated. There's just one more thing that we need to do. We need to actually shroot to this new file system, that this is like kind of the final step. This is like what really separates things. So we can exec root here. Let's see. And now if we do ls, now we are really actually in a container on the command line. Now I should clarify, I do not recommend that anybody actually like does this in production environment. It's a fun party trick. Just, you know, show it to your friends, whatever. Yeah, definitely like use a proper container runtime anytime you're actually using this. Yeah. Any questions about that? Yeah.
So we did like change root and then pivot root. I feel like I got confused in like
So, okay,
where actually.
let's talk about the difference between those two. So a pivot root, it didn't work this particular time, so I just skipped it. But what it does is if you have two potential root file systems, right? Like you have your actual root, and then within that you have like a container file system, say. So it's just like a normal Linux file system. In order to like, there's a command pivot root, which you would basically never use unless you actually were like creating a container, that makes it so that you can switch them. The shroot, what that does is it makes it so that that particular process's root file system is whatever you say it is. Yeah. But yeah, in order to like really actually create a container, you need to like pivot the roots and then unmount the old root and then shroot again. It's weird. I know it's weird, but it's that last shroot. The reason for it is because the bash, the actual shell that we had before we did the shroot, was actually the same process as from when we did the unshare, like before we did the. It's from the original host. Like you're running a program that's from the original host. The exec shroot sh will grab a new shell from your container, and then that's where your container starts. Does that make sense? Where we left the purpose of it was to leave the old shell process behind and grab the new one from the container.
Is there a way for you to like draw it out? I don't know if it's too complex. You don't have
It's a little bit complex to draw it. I don't even know. I don't even know how to raise these things, but yeah, it's don't worry too much about it. It's okay, but yeah, this is just a nice party trick, I think. Yeah. Okay, let's see how much time do we have left. 30 minutes. All right. Well, let's see what we got here. For your information, that demo that I just did is derived from Jerome. I'm not going to try to pronounce his name, but he's somebody from the Moby project. He has a bunch of really, really great presentations on YouTube. Yeah.
In the terminal, where were you getting the Docker image from?
Oh, where did I get the Docker image from? I just got it straight from Docker. So if I take a look at our demo script up here, here's what I did. I ran an Alpine container, but I just ran the true command. The true command is just, I mean, it's like pass in Python. It just does nothing. It just returns, positive, whatever. When you run that container, you can use a command docker export to export the file system of that container, right? So I basically just ran the Alpine container, and then I used a docker export to just, export it to our file system. Yeah, it's just a trick to like actually export a file system to Docker. It's just how you do it.
Is it different from Mac OS?
I don't know if this would work on Mac. I don't know if the docker export command works on Mac. Yeah.
Is this the only way to like allocate space for a container is to like set up the Docker and then export it to your file system?
Well, if you need to do this, you're probably doing something wrong. There's probably a better way to doing whatever you're trying to do. Yeah, I have used containers like since I was 16. I'm 24 now, and the only time I've ever needed to export a file system like this was for this demo. So, yeah, come talk to me after if you have a question about something specific. Yeah. Any other questions here about anything this demo? Okay. Further reading that I would suggest that you do, there's this great author, Liz Rice. She's written a book called Container Security. It's an O'Reilly book. Definitely a great read. It's nice and thin. There's this great person, Jessica Frazil, she's part of the Moby project. She was like one of the early people in Docker. Basically everything she's ever done is really awesome. Also from Jerome. And yeah, there's also like a ton of code that you can read. Unfortunately, it's all in Go. Sorry, everybody. Yeah. I mean, we can keep talking about the container security stuff at Anubis. Like, I have a whole nother presentation that we can go to if anybody wants to stick around. But I think other than that, you're free to go. Yeah. If anybody has any questions or like wants to get in contact with me, feel free to come up here. Yeah, cool. Thanks for coming, everybody.
I guess I had questions about how it actually like allocates the space for the container.
When you say space, what form of space are you talking about?
I'm assuming it just like takes a section of memory or whatever, and it says this is going to be our container now. Or like, how does
It's just normal
virtualize
memory.
that?
It's just normal memory.
It's just straight up normal memory. It says this is ours now.
It's like the same tools that we use to separate the memory from the from like a host and for like a process.
Oh, okay.
It's the exact same thing.
Okay.
It turns out like all you actually need to do is just separate those other types of resources, and then you're off to the races. Boom, you have a container.
Okay, I didn't know if I was doing something like weird and fancy.
Yeah, no. I mean, you do use C groups to limit the amount of memory. That's
okay. So that's
the way that you use that.
makes
Yeah,
sense.
yeah.
Okay. Thank you.
Yeah.
Appreciate it.
I have a question as well. This is kind of related to like Kubernetes and stuff. I accidentally drained all nodes at the same time. Now it's kind of screwed up.
Yeah, that would. I don't even know how you would cold boot that. Yeah, that's interesting. I don't know how you would fix that. You should do backups of everything. So like, okay, let me tell you how we do backups on Anubis. The main thing that we have to back up is obviously the database and the student volumes. We have two ways of doing it for volumes because we cannot lose students' homework assignments. We basically take a full backup of everything every 6 hours. I would do that. Yeah.
I mean, it's not a production cluster. Right now, I set up a Longhorn so that it kind of does the backup.
We use Longhorn too on Anubis, and I wish that there was something better than Longhorn.
I don't think there's anything better than Longhorn. Other things like stateful sets. That's like the absolute basic, right?
Whoops. That is why Longhorn is difficult for us.
I understand that.
Yeah. Okay. Sorry. Go ahead.
So,
your backups should not be on Longhorn because it's all in cluster.
So what else? What other solution?
You have to back it up somewhere else. So you can use if you were using hosting provider, I would tell you, okay, you can use a volume on your hosting provider. But because Longhorn runs within your cluster, that means that like if your cluster gets messed up, you lose your stuff. Longhorn does have a backup system, but it's not great. That's the whole reason why I wrote an entire secondary volume backup system, just because Longhorn's was just not reliable enough.
Oh, okay.
Where is it? I mean, in theory, you could use this. Like, I wrote this whole secondary thing. It's just, yeah.
If I like add a new node to the cluster, would it fix anything?
Would it fix anything? I don't know.
Because
That's
right
difficult
now,
for me to
like
say.
everything is like the control plane, etcd, worker nodes. Everything is on the same. Like I've configured it so that there's no master node. Everything is a master node.
Well, that's what Kubernetes is.
No, you can set it up such that.
I guess Rancher has specific master nodes. I'm not sure. I'm not sure how you would handle that. You might have to start from zero.
Yeah.
I hope your data is backed up.
Yeah, this is what it looks like. So I have a production server at home, both. So this is stuck. It is stuck in here. Even if I reboot, it wouldn't do anything.
How do you have k8s.bobs.nyu.edu?
No, I have special privileges at both.
Okay.
So I can set up servers and stuff. Yeah. This is pretty cool. Like all of them, it has good port security. So every time you plug in, there's this software we use called DNS Manager. You get every thing you plug in. It is divided into different.
This is part of IP Manager?
Not IP Manager.
Okay.
I work for the both ITS, so
Yeah.
I have a lot of internal tools. So it's called DNS Manager. So everything, all the Cisco switches, they're so cool.
Mm-hmm.
So
Yeah, I used to work at Cisco. They got some cool stuff.
yeah, so it gets a different IP. So sorry, everything that you plug in has to be registered on the network using its MAC address, and it's